Picking up where we left off yesterday in lesson 7.6. We were dealing with natural logs. What's the base in a natural log? E. Ln stands for the natural log, and then it's base E. Do we remember what E is? Okay, it's a number. It's on the calculator, 2.718, yada, yada, yada. Okay, just some memory jogging. At the top, we were using our properties to combine those logs, right? So we are using our product property, our quotient property, and our power property. Down here, we were solving these equations. What's the idea we were using that I don't have written down today? Yeah. Left, right, middle is the theme down here that we were using. As you can tell, my BenQ shut down overnight, so I had to rewrite things out. Well, I guess you can't really tell because I erase it all and write it again for 6 hours. So now, if we look at B for a moment, brief recap, right? We have one natural log equal to a number on the other side. Natural log is base E. So we did our left, right, middle. E to the fourth is 3x plus 5 squared. And then remember, I made a point of saying, what are we solving for? We're solving for x in these, right? We're not solving for E. E is no longer a letter. It's a number right now. So we're solving for x. So in this particular one, we took the square root. 3x plus 5 was the square root of e to the fourth. Square root of e to the fourth was e to the second. When you take the square root, we have to consider plus or minus. Solve for x, right? We subtracted 5 over, so it's negative 5 plus or minus e squared divided by 3. And this is where I said, try in your calculators, yes? And make sure you know how to put this in the calculators. What answers were you guys getting?
Which one?
Oh, what the heck?
Plus or the minus?
Well, okay, so what's the positive answer you guys
I
have?
actually don't know.
2.389.
No, definitely
I
not.
got 0.729.
What'd I do?
7.85.
I got
0.796. I got 0.796.
I didn't divide
Okay.
by 3.
Okay.
This was yesterday.
Now, I have 0.796 is one of mine.
I didn't divide by 3.
And my negative answer,
Negative 4.130.
when rounded, is negative 4.130. So I think you said 4.129.
Yeah.
So I'm sure that was just a rounding glitch.
It was. See,
I forgot to divide by 3.
Now, okay, forgot to divide by 3. Real quick. Again, are you practicing these on the calculator?
Of course.
Because you can write them down all you want, but then when it comes to your own quiz or test, that doesn't really work anymore, does it? So, I encourage you to practice because the advantage of practicing right now, you have a teacher that can help you, you have your peers that can help you. So, if I was doing this, I would do the numerator first, negative 5 plus e squared, and then you need to hit equals here, unless you put that whole numerator in parentheses. So I would do negative 5 plus e squared equals, and then I would take that number, this looks familiar, doesn't it, and divide by the denominator of 3. And there's my first answer, 0.796, and the 3 tells the 6 to stay. And then I would repeat. This time it's negative 5 minus e squared. I would hit equals after I get that numerator, and then I would divide by 3. Negative 4.129, except the 6 is going to tell the 9 to go up. Well, when we started talking about telling the 9 to go up, think of it as what does a 29 go up to? A 29 goes up to a 30. Okay, we got the calculators working. And again, I am always more than willing to help with calculators. Yes?
Every time I click the negative button.
So clear it,
And then,
and then, oh, you're using the minus button? Use the negative button, that negative button.
alright.
I know. You would,
I'm not used to it.
it would be nice if a minus and a negative were the same button on the calculator. On some calculators they are.
Yeah.
These
On the one I
calculators
used
not.
it was.
Okay.
That's-
Yeah, and that's where I say, you know, be familiar with the calculator you like to use. And if you have to use mine, be familiar with mine. All right. Okay. Any other issues? Okay. Have you started C?
I got E, just equals and nothing.
Okay. So what's different about this problem?
There's no parentheses.
There's 2 logs instead of 1 log. Does left, right, middle work when there's 2 logs?
No.
Not yet. How's that for an answer? Okay. In other words, I can't use a left, right, middle when I have log plus log equals something. I have to have a log equals a number, or whatever the case is. So, how do I take these 2 logs and make them 1 log? One of the properties. Okay, there we go. We're on the right track.
Yeah.
2 logs being added can be rewritten as 1 log where the insides are multiplied. So I can rewrite this as the natural log of 2x times 3 equals 2. But in all reality, what is 2x times 3? 6x. So really what I would write is the natural log of 6x equals 2. Now what can I do? Now we're ready to talk. Left, right, middle. What base is a natural log again? E. So, left, right, middle. My base of E on the left raised to the value on the right, which is 2, equals the middle. What's inside the log? 6x. Well, even though this one started more difficult, it actually finishes easier if you ask me. How do we solve for x? If it's 6 times x, we're going to divide by 6. So when I divide this, I'm doing whatever e squared divided by 6 is. Try the calculator, right? I would do e to the second. You have to close that parenthesis after the 2 on my calculator. And then divide by 6. And that will work for my calculator. What'd you guys get? 1.232? Yeah. Comes up 1.231. The digit after the 1 is a 5. 5 and up always tells us to round that previous digit up. So approximately 1.232. And again, both it works here, and there's only one answer because there's no square root here. I did forget to mention, back on B, did you guys check and make sure B, this negative worked? Probably not, because I forgot to mention it. Will a negative work here?
Yeah.
Yes, because when I put that negative in, okay, I may get a negative, but I'm going to square it. And when I square it, that makes it a positive inside the log, so we're okay there. Okay. Yes?
Does it matter if we put a straight angle sign or like a wiggly one?
Technically, no, it doesn't matter. A straight equal sign I use because it is exactly equal. I use the wiggly equal sign, which just says it's approximately equal to, and the only reason I did that is because it's a rounded answer. But I don't really care what you use. I mean, you could just say equals, it's fine. But that's the reason I use the wiggly one. Now, D, I don't really plan to go all the way through because it's going to be a lot like our first two problems. However, I do want to do one step in it. What would be the first step? Before I can do left, right, middle, what would have to happen?
6x squared plus 1 squared. Wait, what? 6x plus 1 squared.
Okay, so in other words, this 2 would have to go to the power, yes? And so then you would have natural log of 6x plus 1 quantity squared equals 3. And then, I don't know about you guys, but this looks a lot like A and B, doesn't it? Okay, it looks a lot alike A and B. So for that reason, I'm ready to move on to the back side if you don't mind. Yes?
But how would we do the 3?
Yeah.
Though? How would we get the square root of that?
You could just leave it in a square root sign and then plug it into your calculator. Yeah, oh, because the other one was the square root of e to the 4th. Yeah, I would just write it as plus or minus the square root of 3 when the time comes.
Okay.
Oh, I see, because it's going to be in the exponent, right? Yeah, I would just leave it as the square root of e to the 3rd. That's what it's going to be, sorry.
Okay.
Yeah, just leave it as the square root. You can type that in your calculator. Okay. Backside. So we just solved natural log equations, right? Get one log by itself, left, right, middle. Now we've got to solve exponent equations. X is in the exponent. We've solved exponent equations, except when we solved exponent equations, we didn't have any e's, did we? This is officially where the gold paper came into play at first. Because we'd say, okay, can you get the bases to match? Now, before we do this, your first step here needs to be, let's get the power by itself. So how do I get this e to the 2x term by itself? Hold the divide by thought for a moment. Do something else first.
Minus 2.
Subtract the 2 over. In other words, I'm trying to get e to the 2x by itself. So let's subtract the 2 over. So then I have 4e to the 2x equals 14. Is my power by itself. In other words, not quite, because I want the base and the power by itself. So is e to the 2x by itself? No. Now what do I do to get e to the 2x by itself? Now I'm ready to divide by that 4. The 4's cancel on the left, and I have e to the 2x. 14 divided by 4. Yeah. My brain reduced it to 7 halves. But then I also know 7 halves is 3.5. You could say 14 fourths, 7 halves, 3.5 is going to be easier, right? Now, this is where, back in lesson 7.5, we started with, okay, I have a power equal to another number. I'd hold up that gold paper and say, can I get my bases the same? Are we going to get an E and a 3.5 to be the same? No. So that's why the gold paper is kind of irrelevant when we're talking with E's. So what was plan B if I couldn't get my bases the same using the gold paper?
Log.
We took the log of both sides, right? And at the time when we took the log of both sides, we wrote the abbreviation LOG in front of each side, yes? We're going to tweak that a little bit. Instead of LOG log, because this is base E, we're going to do ln log. We're going to use a natural log. It'll make the problem a little bit easier. So I'm going to say the natural log of e to the 2x is equal to the natural log of 3.5. Now, the reason I use natural log. What is the base of natural log? It's e. Oh, she's saying about canceling? Technically, it's not cancel, but I know that's what you guys always say. What happens here, guys, when your base of your log and the base of the inside match? Well, it equals 1 if that's what the power is. It equals whatever your exponent is. So in this case, what's my exponent? 2x. So the idea is when those e's match, which is the whole reason I use natural log, guys. Those e's match, I don't even have to move the 2x out front. I mean, you know, that's how we did it with the regular logs, right? I can move the 2x out front and then divide. Here, those e's match, so I can just drop them out and say 2x equals natural log of 3.5. How do I solve for x? Divide by 2. If it's 2 times x, we're going to divide by 2. X equals?
2.626.
Is that the popular opinion? I will be honest and say it's what I have written down in my notes. 0.626. So make sure when you do natural log 3.5, you close the parentheses after 3.5, right? And then divide by 2. Okay. Yes?
You get the same answer if you divide the natural log of 3.5 divided by the natural log of e to the second.
That would make sense. It does. It's another way to work it.
This way is just faster.
It can't. I mean, honestly, it's whatever you see that works is faster. You know, this one, it kind of, we don't have to worry about moving the 2x out front. It's using the idea that this natural log of e to the e, or natural log of e and e is just going to be a 1. So we're left with whatever this is. But no, mathematically, what you did makes sense too. I can follow that. Okay, so B is my power by itself, or my term with my exponent. So in this case, I have e to the x minus 2. Is it by itself? It is. So what do I do once I have that power by itself? What do we do on the last problem once we got the power by itself? We took the natural log of both sides. So I'm going to take the natural log of both sides right off the bat. So natural log of e to the x minus 2 is equal to natural log of 12. You can move that power out front if you want. That's still legitimate. However, natural log of e. What do we know about this natural log of e? It's just a 1, and then we have whatever the power is. What's my power? X minus 2. So we can just skip and say, okay, x minus 2 equals natural log of 12. How do we solve for x? It's minus 2. We're going to add 2. So it's natural log of 12 plus 2. You can enter on your calculator natural log of 12 in the parentheses plus 2, or you can do 2 plus natural log of 12. Either or. What's your calculator work telling you that natural log of 12 plus 2 is?
2.6.
I'm not sure I heard an answer I liked. I don't know.
Wait.
Yeah, that's what I got.
It is 4.485. Okay.
That's the round.
And I'm just having a problem reading. I have a wrong number written over by the 4, and so I was trying to make sure I can read my own handwriting. So, did we get that?
Oh, yeah.
Natural log 12 in parentheses plus 2. Or you can do natural log of 12 equals and then do a plus 2. So 4.4849. Digit after the 4 is a 9. 9 tells the previous digit to go up. Are we getting the hang of it? I was going to do one more and then move to a word problem and then try and give you guys a little bit of work time. C. 2e to the negative x equals 20. Is my power by itself.
Yeah.
Not quite. I need it to just be e to the power. So I need just e to the negative x. Nothing added to it, which is fine here, but nothing multiplied by it. So how do we get rid of the 2?
Fraction. Oh, wait, what?
We're going to divide by 2. So then I have e to the negative x equals 20 divided by 2 is 10. Take the natural log of both sides. Natural log of e to the negative x equals natural log of 10. What do we know? Natural log of e is base e, right? Natural log of e is just going to be 1, so I'm left with negative x equals natural log of 10. How do I get x by itself? Not add 1. Divide it. You can divide it or you can multiply it. So I can divide by the negative 1 there. Or you can multiply. So you can do natural log of 10 divided by negative 1. Or you can do the negative of natural log of 10. I think that's what mine says. Negative 2.303. I have another situation where I made a mistake, wrote over it, and it's hard to read. So, okay. D. I'm going to. I'll write the answer down here if you want it. If you want to try that later, or if you've already tried it, 0.434 is what I have there. And I want to talk about this word problem here. Your favorite, right?
No.
Has lots of words, I'm sorry. Okay, a spacecraft can attain a stable orbit 300 kilometers above the Earth if it reaches a velocity of 7.7 kilometers per second. The formula for a rocket's maximum velocity v in kilometers per second is v equals negative 0.0098 t plus c ln r. Okay, and it was a stable stable orbit 300 kilometers above Earth if it reaches a velocity of 7.7. The booster rocket fires for t seconds, so t is time. The velocity of the exhaust is c kilometers per second. The ratio of the mass of the rocket filled with fuel to its mass without fuel is R. So you have to read, but they're telling you what all these letters stand for. Suppose a certain rocket has a mass ratio of 25, a firing time of 100 seconds, and an exhaust velocity of 2.8 kilometers per second. Can the spacecraft attain a stable orbit 300 kilometers above Earth?
I guess we're gonna find out.
We're going to find out, is right. Okay, let's go back here to this sentence. Suppose a certain rocket has a mass ratio of 25. What letter represents mass ratio? R? So I know R is 25, the ratio of the mass. A firing time of 100 seconds.
T.
Well, it's time. Of course that is T. And an exhaust velocity of 2.8 kilometers per second.
C.
Velocity of the exhaust is C.
Just pull that in.
Okay, that's helpful to know, right? We got all that information. And they gave us a formula of V equals negative 0.0098 T plus C natural log of R. Didn't they just give me R, T, and C? Isn't that what we need to fill in this formula to find velocity? It is. So start plugging your numbers in. V equals negative 0.0098 times T, which T is 100, plus C, 2.8, natural log of 25. See what you can do with the math there. Hello? I sure can. Bye. Okay, guys. Did you get that real quick? 100 was time. I put 100 in for T. C, exhaust velocity, was 2.8. Natural log of R. R is mass ratio. That's 25. You can put this all in your calculator at once. I encourage you to try it. What did we get? 8.033? I have 8.03 written in my notes. Okay, so, as I said, I would enter this all at once. I would say negative 0.0098 times 100 plus 2.8. You can say times natural log of 24, or you can just type natural log 25, sorry. 8.0328. 8.03 is what I have written down. 8.033 makes sense. This is velocity. What's my label for velocity? In this case, it is kilometers per second. Now, what's the question asking? Can the spacecraft attain a stable orbit 300 kilometers above Earth? What has to be true for it to attain a stable orbit 300 kilometers above Earth?
7.7.
It has to reach a velocity of 7.7. Does this reach a velocity of 7.7?
Yes.
It certainly does. So my answer to the problem is yes. The velocity reaches 7.7 kilometers per second. And again, that information was given at the beginning of the problem, right? I'll let you do part B if you want. Notice it's asking the same question, isn't it? It says a booster rocket. It gives a mass ratio, an exhaust velocity, a firing time, and it wants to know if it can achieve a stable orbit. So you're doing the same process. Okay. I'll write down the final information here in case you want it. And your homework to get working on is lesson 7.6 in Math Excel.